If any issue with the food, tea, let me know. I'll ask the caterer to provide a better quality food, right? So I welcome you back to this post-lunch session on the third day of this GAN program. Uh, Yesterday we have a very good tutorial, interactive, a very good participation from your side with foreign expert, and this is another very good session. I hope it will be a good session in the sense that this is not the theory, this is the practical. So in the last 2.5 days, we have learned, we have seen a lot of data on climate change, migration, displacement, and so on. So very interesting data. But this session, I'll be demonstrating you how to use those data for the meaningful output what has been shown, so that you can do on yourself. Uh, I'll be showing in a few slides what are data set, from where you can get it, how you can convert it in a GIS domain, and then how can you run the model on your own. It is a big exercise, but the data what we have, the spatial data in terms of satellite data and non-spatial data which is available for a very long time, that has made the task better, easy, and that gives a very good result. Earlier, if you have to have a data on climate, on rainfall and all, you have to spend months and months. But now these data is at your hand. You can download in half an hour, depending upon your how many session you have for how long. So the title what we have is that of exercise one, uh, and the title is Climate Change Vulnerability Assessment using Climate Extreme Indices, a fuzzy logic based approach. Fuzzy logic based approach. So if you see this one, from where all data we can get it, uh, when we want to model, uh, climate change, and I said yesterday and today also that when we talk about climate change, two most important drivers of climate change is temperature and precipitation, and everything room around it. With varying temperature, vegetation change. With varying rainfall, vegetation change. Crop change. Everything gets changed. So what we have, from where we need to get the data? The data we get it from India Meteorological Department portal, and portal is already given, imdpune.gov.in. That is headquarters is in Pune, right? Earlier when we started research, we have to write a letter, we have sent to speed post, registered post, and then it takes months and months to. You can get the data daily, long-term graded climate data. For this exercise, we have taken the temperature and precipitation, and from temperature we have taken a few indicators, different indices, and for rainfall we have taken different indicators, indices. That can be downloaded. User can download state-wise graded data. You can define your boundary, and based on that boundary, within that boundary, you can download that station-wise and the boundary-wise. Or give lat long extent you can give. Okay, say for example 77 to 79 longitude, 28 to 29 or 30 latitude, you can make a grid, square, whatever. Or in India we do not have the state, very straight boundary like in US. If you see United States of America, 50 states, they have very straight boundaries. But in India we have zigzag boundary. Most of the countries have. So you can get the extent, latitude, longitude, and go to the IMD Python library. IMD Python library is this one, IMD library read threshold document dot in dot and then slash latest. Python user can install library using pip install imd lib and fetch data using import imd lib library. And useful, it is very useful. You can retrieve, you can download, extract the very useful information on rainfall and temperature and many more things, right? You can note it down and then make a, maybe you can make a photo, or I will share the all the presentation PPTs on the drive that has been created for this course. Let me, what happened? इस पे निकाला मुझे उसको स्लाइड से बढ़ा दो. I'll move it. उसको करके दो मुझे. Then what you have? I put the screenshot. I have made this PPT with the help of my students so that anyone layman can understand how to do it and how to get it. This is website. What I showed you. imdpune.gov.in, and this is the what you have to do. You have to register like Google, Yahoo account, create an account, and then you go for different data format. Radar data, session data, report data, tabular data, and then once you create an account, you can log in and go ahead, right? Then still not working. देखो क्या हुआ? करके दो ना, move करके दो ऐसे क्यों? Then what you do is, you go to this yearly graded rainfall data. This is 0.5 quarter inch by quarter inch data binary. You have 1 degree also, quarter degree also, right? This is for the rainfall data, and you can go for clickable sample, photon code, and there are different codes here. Nothing to worry about the codes. You can get the codes, and you do not need to understand much of the codes. But you download it and then use that code to run that, right? Then still not working. चला के दिखाओ ना, तुम हमको क्यों पकड़ा दो? कहाँ चल रहा है? कहाँ मूव हो रहा है स्लाइड? स्लाइड्स कहाँ मूव हो रहा है? स्लाइड शुड मूव ना? स्लाइड इज नॉट, उसको निकाला है? यहाँ लगाना है, तुम लोग भी क्या कर? इसका वो लगाया नहीं. अब वो निकाल दिया तो चलेगा? फिर I'm sorry for interruption, right? Then you get this kind of data, graded data, 1 degree graded data, right? So this is use IMD graded data, daily precipitation, maximum minimum temperature. Convert this data into Excel format using Python code, right? And then save this file as a Excel file, .xlx. And then after that, you save that file as a text format so that you can use in RStudio statistical software. So there are 3 issues. One is convert data into Excel format, use a Python code. When you click earlier on our earlier slide I showed you, you'll get the code, and then save that file as XLX as a text file. So this is a graded data. You can see these are the grids. Square shape. There are 3 grids here. There are 3 grids here. You can see maybe somewhere 1 grid, 2 grid. Then this grid data has to be converted into XLS format. What is written? No, .xlx. What is that? The .xlx format. So you see, this is the year 1984, and it's very long row. We use this data from 1984 to 2024, and daily data, daily rainfall data, and this is the month, and this is day 1, 2, 3, 4, 5. This is a screenshot of that. And then what we have, these are the parameters, and this is the date and time. So what we have, how much rainfall has been recorded. Here you see, there is no rain on this day, there is no rain, there is some rain here, there is some rain here, like that. Then what we did, we convert this data to the text format, the last point what we have. 1964, it will get converted to this format, so from graded data to XLS format and then to text format. These are 3 steps. These are 3 steps. Then in RStudio, you go on this Climate's website. Website is already given here. Climate's project offers a range of climate extreme indices. These indices are annually or monthly statistics for modeling observed climatic data. So what we have? These are the different indices. Somebody was asking yesterday about the indices. Yesterday somebody asked. I said I'll show you tomorrow. So these are the n number of indices what we have. These are the heat and cold indices. What we have? FD, SU. I put here for some FD, that is number of frost days, FD. Number of frost days. This is annual count of days when temperature, daily minimum temperature is less than 0 degrees centigrade. You know? So the second parameter SU, SU is the summer days, number of summer days, annual count of days when temperature maximum daily maximum temperature is more than 25. Yesterday some participants were talking about, okay, we have a data, yes, is sitting there. Okay, we have a data of more than 25 degrees centigrade, and in India all the year round we have, bearing January, December or November, we have more than 25 days. So data is more general, but it is not so. The expert sitting at the Columbia Climate Institute and many other institutes, they customize, they put it, they make it in a way that it should represent fairly to the different regions, right? So this is another indicator. Then ID, you have IC days, number of IC days, annual count of days when daily maximum temperature was less than 0 degrees. Similarly, you have n number of data, see, more than 20 data, and these are the codes. When you click it, you will get what is this. Then heat and cold waves, these are the different indices. And when you go for precipitation, this is RX 1 day, RX 5 day. So this is RX 1 day, that is maximum monthly maximum 1 day precipitation. 5 day RX 5 day, that is monthly maximum consecutive 5 days precipitation. R20 mm, that is a annual count of days when precipitation was more than 20 millimeter or more, right? So we took this data, we took this data, we took this data. You can select the data, and I yesterday told you that you have to select the parameter and the data indicator. You cannot take all because of time, and and there's no point taking all. So you have to read the literature. Okay, which data will be useful for my study area? You take certain parameter, choose certain parameter, run the model, see the result, and always say, yesterday I was saying, do not go for statistics, go to the field, validate. If not, come back and take another parameter and run the model, right? You need to run the model. You should not be in a hurry. So these are the indices that is available on the website. What I have put it there, right? If you have any issue, please raise your hand, discuss, because this is not theory class. This is a lab exercise. So you note it down and raise your hand. We can clear immediately on the same, right, on the same point. Now, following are the folders. These are folders for indices. These are the folders for indices. When you go to this, you will get certain indices. You go to this, you will get certain indices, right? And these are the codes. These are the codes. So what we have, see here, these are indices. There are definitions, say 27 core indices. What I showed you, FD, frost days, and similarly these are the little bit explanation what is all about. Not just one line, what is all about. TG, be the daily mean temperature on a day that is in a year. J is a count of number of days between first consecutive occurrence of at least 6 consecutive days, and so on. So very precise, very fine, refined parameter has been made, and accordingly data has been put by the scientists on these portals. No, just wait. Sorry, I pressed this one. It's coming. By mistake, I pressed this one. It's coming. वहाँ पे तो नहीं रहा नहीं यहाँ तो नहीं रहा It's coming, wait. It's coming. Wait. हाँ ठीक है आ रहा है right. Then what we do, we took, I said we took 6 indices. In fact, he has taken 18 indices. Resolve is part of resolve work. We took it to demonstrate you how we can model the climate vulnerability. We took 6 indices to save time for your exercise. Extreme indices that is there on the top for 20 station. Is a part of the Bias River Basin. Uh, from that there are 20 stations. There are 20 watershed. Therefore, there are 20 stations. So what we have? We join the results of these indices in ArcMag for visualization. From this point of further, the GIS software starts its working. Till now, what you need to do is go to IMD website, download the gridded data, convert it into XLX, and then convert it to text format. Right? And before that, you need to select the justified judicious selection of parameters. Once you get it, you have to create a shapefile of a study area with point data where you will going to link it. Because when you say the rainfall, what we used to have earlier at a large station, there were hardly meteorological station, and even today there are few meteorology stations, weather stations. It is difficult to install, difficult to monitor it, just difficult to maintain it. In that context, what has been done? The agencies are using satellite data, and that has been converted to grid data, and then you convert it to for each and every location in a pixel format. So in the sense, there was no data. We have quite close to the reality, the data. From where we have got it? Yesterday, what I talked about, power of remote sensing satellite data, right? So this is a dot text file. So what we do is we input here this file, and then somebody play from there. Otherwise, se ho jaye. Ek aadmi wahan khade jao. Right? The text file, go back for one more back. और जाओ, और पीछे जाओ. Yes, this text file, the third output, what we got it. Go further. We upload this file. Here in our Climate Extreme software. Then we go for output. We click on the output, load data, and then click. Then we get the output like this. Right? So what we get? This is the basin number 1. It can be name, it could be number. Latitude and longitude in meter. Latitude, longitude, normally we read in degree, minute and second. But when you go in image processing software, GIS software, we convert it to UTM projection, and then it is in a meter. So what we have? These are the indices. T and M. This is a temperature. This is a maximum temperature. This is rainfall. This is rainfall, and this is CCDs, consecutive dry days. CWD, consecutive wet days. Next, please click karo. So these are the indices. What he has taken. Say first indices. Maximum 1-day precipitation. See the third column. Maximum 5-day precipitation, consecutive dry days, consecutive wet days. Annual total wet days precipitation, daily precipitation intensity, that is very important, what we have seen today. This is daily precipitation, number of heavy rain days, number of very heavy rainy days. Then in temperature, maximum temperature, TXS, TNX, maximum temperature, minimum, mean temperature, minimum, maximum temperature, minimum, maximum, minimum temperature, and then mean temperature. The number of cool night. This is another very interesting parameter. Number of cool nights, number of hot nights, number of hot days, number of cool days, number of warm nights, number of hot days. Sometimes we experience hot days but cool night. Sometimes we experience hot night but cool days, something like that, because of certain reasons. And these are the units. Somewhere in millimeter per day, somewhere in degree centigrade, somewhere in a percentage. Next, please. Now, then we go to add extreme climate indices data to station attribute table and visualize in the ArcGIS software. What we do? This is after calculating 9 indices for every station from 1964 to 2023. It is how much? It is 64 years. And to have a better result, we need to have longer period of data. Data is available even, you know, uh, beyond say 1964. I think from 1920 or 18, huh? 1901. Imagine. So you can take 1901, but we took it 1964 because after getting freedom and then mostly started some other activities little later. So therefore we can take from 1984 also. Add a station shape file in a JS software, join manually, edit attribute table, and export to the new file for the next please. I'll show you now. Uh, this is I've already showed you. Next please. Now we have come to the uh, special platform, geospatial platform. What we have? This is a main window of our GIS software. We add this is a basin boundary. You need to decide it. From where you can get it? You can get it from watershed atlas. It's very common. It's very important. No? Watershed atlas. Therefore, I say GIS and remote thing do not give everything. You need to use. Somebody asked yesterday कि पुरानी चीजें कुछ था कि पुरानी चीजें क्या obsolete हो गई या कैसे होगा. तो then I said कि this topo shade still holds its value. We have the watershed address. From the watershed address, what is the study area? You reference it and then digitize, and these are the centroid of each watershed boundary. And then वहां से वो तार हिल रहा है ये दिस वन जो इससे कनेक्ट हो रहा है. दैट इज अ प्रॉब्लम है. उसको बुलाओ. कॉल हिम. कॉल दैट टेक्नीशियन. है अभी हम सॉफ्टवेयर पे आएंगे ना. उससे कैसे करोगे? वी हैव द सॉफ्टवेयर हियर ना. उसको बुलाओ टेक्नीशियन को. व्हाट वी हैव, we link it. I'll show you how to put it step by step. We link it. जो लोग करते हैं जानते हैं उनके लिए बहुत आसान है. But those who are not doing, for them, once we link it, you'll get the attribute data that is linked in a special domain. Next, please. Then we go in ArcGIS. There is a operating toolbox. That is the toolbox. In toolbox, go to spatial analysis, then go to interpolation and do interpolation. There are n number of interpolation techniques. One is very commonly used. One of the best interpolation technique is IDW, inverse weighted distance. There's another technique that is called moving average. There is another called kriging. There is another co-kriging. Many. So I do not want to go into those details. You must be knowing. If not, then you need to see the textbook. Call the technician. That is the only solution. आदिल को बुलाने को ही क्या? फोन करो उसको. उसको ऊपर जाओ. Go and ask. Okay. Then these are different steps. You chose a file, consecutive dry days CDTD, and give the extension TIFF and define the cell size because each satellite data is own cell size, right? So 30 meter. If you are using Astra data, 30 meter. If you are using any other data, 60 meter. Then you have to have the same cell size of this IMD data. Then go to processing extent and select the basin, and then these are the steps. I'll show you in the software. Next, please. Yes, this is one. Go to the software toolbox. What is written here? Spatial analysis. ये देखिए बहुत डिस्टर्ब कर रहा है. What is the problem? जल्दी देखिए. So what I have written here is spatial analysis arc toolbox. This is arc toolbox, right? Then from there you go to spatial analysis. Spatial analysis here, and then from here you click on this cross. Go to interpolation, and these are the interpolation techniques. As I told you, IDW, kriging, natural neighbor, spyline. These are the interpolation technique. So this is. ये क्यों चला जा रहा है आदिल? तो आप ठीक से कनेक्ट करिए ना प्लीज. कुछ नीचे लगा दिए, सपोर्ट दे दीजिए. कुछ नीचे उसके कागज लगा दिए, कोई चीज लगाइए, क्या करेंगे? अभी तक तो ठीक था सब, इसको क्यों दिक्कत डिस्टर्ब कर रहा है? Right. So what we have here is uh, these are interpolation technique, and these are the main window for modeling. And once you click on any this cross, you'll find many. Once you click on this say spatial analysis, the major category, you'll find many. In the spatial there, convolution, density, distance, extraction, many. So once you click this one, say you'll find many operations. And wherever you get the hammer, that is the last step. You double click and then go for operating. That is operating tool. Right? We'll see in the software. Then after interpolation, you get this kind of map where the consecutive dry days values varies from zero point 0.2 to zero point 0.7. So before that we interpolate. After interpolation we go for fuzzy membership, because when interpolate there will be a wide range of values depending on temperatures in some different unit, precipitation in some different unit, right? As you have seen, something in degree, something in percentage. So you need to convert into a uniform platform. Unless you do not convert into an uniform platform, you cannot draw any meaningful information. For example, if any data of 30 meter, you have data of 5 meter, you have data of 60 meter, and if you overlay, that will give the poor result. So you need to resample at a common scale. So similarly, all these data has to be converted into fuzzy membership. So once we convert these data into fuzzy membership, that values ranges from 0 to 1. So all the layers, you have 6 layers, 18 layers, 20 layers, 100 layers, whatever, that will come on a uniform platform. Then we give the fuzzy membership, we have scaled raster data as input, and then we apply operator. The third line we see gamma operator. In GIS theory, you must have studied, or you will see in the textbook, there are different Boolean operators, logical operators, X, or not, right? So in the same way, add, subtract. So in the same way, you apply a gamma operator, and then uh, uh, on the all 6 layer, and then you get the, see here, these are the different output layers, 6 output layer that has been prepared using the meteorological data. These data layers are in TIFF form, right? Tagged information system form, tagged information format. So all these data has to be converted to fuzzy membership. And for that, what you have to do, go to again ARC toolbox, go for a spatial analysis, and then you go for overlay. In overlay, there is a fuzzy membership. You apply the fuzzy membership, select each layer, and then give the operating overlay method gamma, and then you give the output here. And that will be the final output of that particular one layer. So once you prepare a data, it will take hardly a minute to run the model for converting the data layers into a common scalable format. Right? If you have any issue, any doubt, please raise your hand and let me know. Right? Then After that, what we do is we once we apply it, this operator fuzzy membership, we get the we use and then we go for climate vulnerability modeling by using all the 6 layers, and we get the final output map what I showed yesterday. And this is a vulnerability map where you have the low 0.3 to high 0.7. It varies from 0 to 1, right? And then what we did, we use the census data, population data. You know, the census data, we already know that we have the census data. We go that census data in Excel format. That population data has to be again linked with the point data, centroid data of each basin. If you have 20 basin, 30 basin, or anything statewide, so then you need to do export that map, and then after exporting, you need to overlay separately. Use this, data from Census of India. We all know this is not new to you. This is population interpolation, population overlaying and making into different classes. Say for example, this is the population data from Census of India 2011. These are the state, this is district, the sub districts, population, area and density. You can use population density, you can population total number of population, you can use density, and then you see what is the state of affair in terms of population, in terms of total population or density. Whatever you want to overlay or see the relation. Once we overlay it, the one output was separate, my vulnerability map, that is the most important, and then the population map. This is what I study showed you. These big blue dots has a population of 1 lakh or more than 1 lakh. So that shows what is state of affair, how much people are exposed to climate vulnerability issues by using these 6 indices, right? So this is all about if we talk in terms of presentation, step by step we have noted it down. I'll supply it to you on the website, this portal, Google Drive, sorry, and then we'll move on the software. And I'll show you step by step. You can see, you can note it down, small point, write a special analysis dash something, and then with that note and with this note, we'll move to the departmental lab. Very good, rich lab. इसको ऊपर ले आओ जरा, इसलिए कि फिर I can sit down. ये इसके साथ लगा रहेगा तो ये डिस्टर्ब करेगा. हाँ. अभी तक तो नहीं हिल रहा था, क्या बात है? अरे तो मुझे तो अब एक बार हो जाएगा, फिर मूव नहीं करना मुझे. Okay. So, friends, this is the this is important, stage, and you need to be careful and watchful, right? Once you have installed software in your laptop or desktop, there is icon here bottom, right? Arc map 10.8. Version does not matter. Even version 8 is fair enough, right? So click on this and then the software will open in a moment. It was open, I close it just to show you. So this is the main window, right? Two window will open, you close this top window, right? And then I go to this point. This is a symbol here. It says add data plus, right? Or you can go to file and go to add data, and there is another symbol here plus add data. The shortcut is already placed here, so I go here. There are different options. I'm showing just two options. This one, add data. You need to click on this. Where is your data? Browse your data where you have put it, right? I made a folder, and the same folder you'll find in a lab with the same name, so that there will be not any problem. Then there is an option here, look in. Go to a directory. Go to a directory. It is on desktop. Where I put it? Okay, just wait. मैं यहाँ से ले लेता हूँ. There is another option. There is a plus symbol here. Let me do. This is plus symbol. If you go here, look in, it will not show all the directory. Go to this point plus, and then you'll find here. These are the directory. See, this PC. On this PC, you can go and CD whatever you have a data. We have a data here in the flash drive. I'll go select here, and then there is a data here. Gyan exercise 1. This is a folder where the same folder Gyan exercise 1 you'll find on the computer lab in department on the desktop. All the system they have put it, data in the morning. You select it, and then you go to this file. This is called, sorry, this one, and then say okay, right? इसमें सारा डेटा नहीं डाला था क्या? एक्सरसाइज V1 ही है तो फोल्डर डेस्कटॉप पे डाल देते ना. Yes, this is folder. We need to add n number of data layer can be added one by one to overlay it, to superimpose it. So I can go say this is a basin polygon. This is outer boundary of the Beas River basin, right? Which is the extent of our area of interest. We add this one, then again go to plus. We add another one, that is station data. We add it. This is point data, right? And then we add it again, the third layer, that is sub-basin data, the spatial data. So you can add one or another n number of layers, right? If it is the same projection and same frame, it has the same projection, it has the same datum, everything has to be same. In a way that चाबी जब ही लगेगी जब उस ताले की चाबी होगी, तो चाहे जितनी चाबी हो लगा दो, अगर थोड़ा सा फर्क होगा तो it will not come. So therefore in GIS the most important aspect is referencing, georeferencing. That we call is referencing any map with respect to surface of the earth by using different information, and the most important is coordinate system, datum, and UTM projection, whatever your projection you want to have depending on different parts of the surface of the earth, and then extent and some other information. So you use georeference. The more precise you reference, the more precise it will land on a particular part of surface of the earth. Otherwise, if you extract certain feature, that may land somewhere else. It has to be very precise. So these are the three layers, right? Then if I go on this data, you see left side, this is a layer, table of content. Sometime it goes away, I cross it, it go away. तो बच्चे कहते हैं आप कहोगे कहाँ गया? Go to window and then say table of content, it will come again, right? Many times it happens. So if I go on this, I need to see what is the attribute attached to it. So there is no attribute attached to it. I have put it all these steps. Attribute means these are the station 19 and 10 20 basins, and these are the centroids of each basin. When you calculate the centroid, software does it automatically where it has to be placed. Or if you know that particular point, you go and extract that particular point. To extract, we go for digitization. There are three ways of digitizing. One is line feature, point feature, and polygon feature. We all know. And these are the only three features. All the phenomena, all the any object have on the surface of the earth, be it a natural or human. If we talk about a river, it is a linear feature. If we talk about human canals, it is a linear feature. If you want to map, it could be linear feature. If you want to see any pole and a chimney, any tower, it has a point feature. Or you take any forest area, you take any agriculture area, or built up area, it will be a polygon feature, right? So once you have referenced that map, and if you draw a cursor on a map, that will give you the area, perimeter, length, or if it is a point, it will give you a coordinate, right? So what we have, these are the only data what we have. These are name, number, and these are the latitude and longitude, right? Then we have a station data from text data we have somewhere else, so we need to add it. We convert it in text later on. So what we have the data in tabular form, that is relational data. That is called, when you talk about data structure, that is a relational data structure. It has one river basin has its relation with several other climatic parameters. So what we do is, let me show you this Excel data separately. These are the data what we have. We have derived from the first part what I showed you. So by using all those data, say from 64 to 24, 60 years and more than 60 year data, daily average, imagine 360 days, and then we have converted it and we have got this mean, the one figure. See, this is one figure for this, for particular station. So you get, these are the 6 layers, 1, 2, 3, 4, 5 and 6. So this output we get it here. And then what we need to do is, we need to link it. This point data, see, this is in isolation. This special map point is in isolation. Excel is in isolation. And the most powerful part of GIS is linking spatial and non-spatial data. That cannot be done anywhere. आपको एक मैप दे दें, इसी तरह मैप प्रिंट करके दे दें, और एक्सेल जो सेंसस बुकलेट, मोटी मोटी बुकलेट देता था, कई 100 पेजेस होते थे, आप कुछ कर पाओगे? जिंदगी निकल जाएगी, आप कुछ नहीं कर पाओगे. The most beautiful aspect and powerful component of GIS is linking spatial and non-spatial data. Or not only linking spatial and non-spatial data, it also link different data in a different, which is in different format on a common platform. And that is most beautiful aspect. बहुत पहले एक नेताजी थे, चंद्रबाबू नायडू, अभी चीफ मिनिस्टर हैं, और ये सीताराम येचुरी, ये लोग बहुत इज्जत देते थे, लोग बहुत उनके वैल्यू थी. क्यों? कि कोई भी पार्टी हो, कोई सी आइडियोलॉजी हो, उनको एक प्लेटफॉर्म पे लाते थे. ये बहुत बड़ा उसका कैरेक्टरिस्टिक्स है, बहुत बड़ी क्वालिटी है कि सबको अलग अलग आइडियोलॉजी के एक साथ लाओ ताकि कुछ काम हो मिलके. अगर अलग अलग करोगे तो नहीं होगा. देन कोalition गवर्नमेंट स्टार्टेड. तो सेम वे वी हैव, so you need to link this point data with this the data what we have created, we have made by using those indices. So it will take hardly a minute. For that what we do is, इसको हम क्लोज करते हैं. यहाँ पे देखिए, and to link one very important issue. Just a minute. To link, it has to be unique key. यूनिक की कि जो आपका एक एक एट्रीब्यूट फाइल ये है एक्सेल फॉर्मेट में, और दूसरा एट्रीब्यूट फाइल ये है ना. ये कौन सी फाइल है? इस मैप का है. और ये क्या है? एक्सेल फाइल है, सेपरेट फाइल है. तो इट हैज टू बी यूनिक की. यूनिक की के लिए सी देखिए, इट हैज टू बी ये A00BE1 कहा गया 17 है ना. आप जाओगे तो इफ यू सी A0BE104, दिस इज हियर, राइट. सो यहाँ पे 20 है तो 20 वही चीज यहाँ होनी चाहिए. सो सपोज दिस इज 17 हियर एंड 17 हियर, दिस वैल्यू विल गो टू दिस पॉइंट and it has to be unique key. These two special and non-special data can be linked only when you have a unique key. Or you can create a separate column here. You can add a separate column. You can put the name ABCD, or you can write whatever you say, Delhi, Bombay, Calcutta. But it is always good to have a unique key as a number, because typing कभी गलत हो जाएगा तो अटैच नहीं होगा, an error आएगा. So these are the two unique keys. Based on these, or you can have a FID. Based on this unique key, what we do is we link it. So let us do it in a minute. इसके लिए हम इसमें जाते हैं, सब बंद कर देते हैं हम. No need to open all these. We go to this file, right? Right click and go to option join and relate. What we do is, ये हमने खोला हुआ है, इसको राइट क्लिक करिए यहाँ पे लाके, ज्वाइन एंड रिलेट. गो टू ज्वाइन, राइट. गो टू ज्वाइन. ज्वाइन में जाएंगे तो इस सेइंग ज्वाइन एट्रीब्यूट्स फ्रॉम ए टेबल. मैप तो ऑलरेडी डिस्प्लेड है, टेबल अलग पड़ा हुआ है कहीं सिस्टम में. विल कीप इट हियर. चूज द फील्ड in this layer that the joining will be based on what we are going to, what is the key unique key name. So key name is name, that is based in name, what I showed you na. And then this is choose the table to join this layer or load the table from. This is already here. Choose the table. We choose the table. We browse from here. यहाँ पे जाएंगे हम, यहाँ से हम browse करते हैं. Browse and go to the table. There is a table here. कौन सा टेबल? इसके नीचे indices. This is a Excel table, right? You double click. Sorry. We select this in indices and add. क्या कह रहा है? Indices नहीं है क्या? Why is this giving the problem? नहीं. उसको पीछे आओ, उसको सेलेक्ट करके ऐड करो. ये क्यों कर रहा है ऐसा? नीचे वाले हो, खुला तो नहीं है ये जो है ना, खुला तो था. दोबारा सेव कर देता हूँ. Let me save as a separate file. The error in the file, I saved it again. So let me browse the file. इसको कौन सा फोल्डर में डाल दिया इधर? इंडाइसेस 2 किया ना हमने. यहाँ पे कहाँ इंडाइसेस 2 कहाँ गया सर? क्या कर रहा था? इंडाइसेस 2 था ना? ये कहाँ गया? यार एक्सरसाइज 1 है. एक्सरसाइज 1 तो ही है. इसे just bear with me a minute. कहाँ है? नहीं कहाँ where is that? Name? Where is the file? Indices 2. This is indices 2. We add it and then we take the name, right? And say OK. Let us see. Can you see here? It is only 3 column. Now all the data which was there in relation data format, in tabular format, it has joined here. Right? Now, if you click here, take this identifier key and click on this any point, you get the details. See the details. FID is 1, latitude is this, longitude is this, and then these are the values. Can you see? TNM, TXM, this is the value. You click anywhere or you click here, you'll get the value where, what is this point. So this is the linking. That is the most important aspect of here. Linking special and non-special data. Once you have linked it, after linking what you need to do is, if you close it, it will go away. All exercises will be gone. So you need to save it as a separate file so that it can be permanently saved. So one more step, very simple. What we do is go and select here and say select none. Killer selection. So what I do is, after linking, go to this file again, right? From where we joined, we right click and went to join and relate, right? यहाँ पे क्या हमने दोनों को choose किया? I'll go here down and say data. Go down, right click and data, and there is an option right side, export data, right? Export data. You click on the export data and then browse to a folder where you want to see as a separate file. The original file will remain as same as such. There will no change there. So you browse from here, and this is my working directory. I go from here. This is exercise 1, GAN exercise 1, and say OK. Select and say OK. Let me do it again. नहीं तो ब्यास बेसिन दे रहा है ना. नो हाँ तुम लोग बहुत अंदर चलेगा ना. दैट शुड नॉट बी. कौन था वहाँ? तो हम जा ही रहे हैं. हाँ इस देयर रिसर्च में आ रहा है, नहीं आ रहा है. यू शुड हैव गॉन. सो इनसाइड डेटा इतना अंदर नहीं डालता. हमने बोला था कि बाहर डालो. चलो पुट इट ऑन डी. लिव इट डी में छोड़ो. सो सेलेक्ट योर this is GAN exercise 1. Now it comes. So you give a new name, and to be make sure because you have n number of files and each file has n number of support files. तो बहुत मुश्किल होता है. सॉफ्टवेयर में एक फाइल डिस्प्ले होगा लेकिन उसका सपोर्ट फाइल 4-5 होती है. तो इट इज ऑलवेज गुड टू हैव द सेम नेम. कि इसको क्या करेंगे हम इन पे, आई राइट इट हियर, joined, joined, joined export output, and that will be shape file. I say okay and say okay. It says you want to add it. I say no. I close all and then we'll see. इसको सब हम बंद कर देते हैं, इस पॉइंट को हम हटा देते हैं, राइट. और फिर इसको जब हम ओपन करेंगे तो व्हाट आई विल सी हियर, हमने कहाँ डाला, ज्वाइंट एक्सपोर्ट, राइट. एंड देन यू चेक इट, ऑल द डेटा इज देयर. आप नीचे इसको ड्रैग करके जाओगे तो सारा डेटा आपको मिल जाएगा. कैन यू सी, राइट. एंड इफ आई ऐड a layer, special layer, what I had before, you will not find the data. Where is the idea? If I go this station data, and if I see this one, it will be only latitude and longitude. So be careful. After joining, you have to export map, right? So this is one step. इसके बाद next step, if you have any issue, please let me know. Otherwise, I'm sure that we'll have many issues when you go to the lab, when you start doing yourself. So first is IMD data, grid data we have converted to relational data tablet format में किया. उसको करने के बाद then what we have done, we have gone to the GIS software, we have attached data. The second step. Then the third step is that to interpolate. Because before GIS, we did not know the value. If say this is a rainfall here, 30 millimeter, here say 40 millimeter, what is the rainfall in between? Nobody knows. And there was no data. You know? So what we have, once we are using these 2-point data and we interpolate, then we get the value of any point. When you put your pen anywhere in between इसके चारों तरफ, wherever you put your point, you will get the rainfall value. So that will be very close to ground reality. So at a time where then there was no data, but you have very close, precise data, much closer to the ground reality. So that is the beauty of interpolation. So how it works is a strong mathematical calculation, triangulation. आपने पढ़ा होगा. Say for example in one line, अगर हम एग्जाम्पल दें जो बच्चों हम देते हैं, हम यहाँ खड़े हैं, दिस इज माई कोऑर्डिनेट है ना, एक्स वाई एंड वाई होगा कुछ, लैटिट्यूड लॉन्गिट्यूड. इफ आई मूव हियर, चेंज हो गया, लैटिट्यूड सेम रहेगा बट लॉन्गिट्यूड बदल गया. इफ आई मूव हियर, लैटिट्यूड लॉन्गिट्यूड दोनों बदल गया. एंड माई पोजिशन विद योर पोजिशन विल ऑल्सो चेंज. आप यू आर स्टैटिक बट मैं चेंज हुआ तो मेरे रेस्पेक्ट में आपकी भी लोकेशन बदली. So it triangulates. Trigonometric operation use करके the software developer have done it so that you get the precise values. It's very complex, network data. So जो values ये 20 हमारे हैं, इन सबको लेते हुए कि यहाँ घट रहा है, यहाँ if I go from here, it is increasing or decreasing. If I go this side, it is increasing or decreasing with respect to this of this value, and based on that, it takes the precise value which gives you the spatial data interpolation. So let us do it. The second step, and for that there is icon here. यहाँ पे देखिए छोटे छोटे tools हैं, and this is most powerful tool. तिजोरी है GIS की. Click on this, and these are major modeling domains. जैसे मैंने कहा यहाँ पे क्लिक करोगे तो बहुत सारे आ गए, फिर इस पे क्लिक करोगे तो बहुत सारे फिर आ गए, फिर इस पे क्लिक करोगे तो बहुत सारे आए, हजार हैं. We do not know much, we know little. My students know more than me, much more than me. शायद आप में से बहुत सारे लोग जानते होंगे. तो हम लोग उतना जानते एक्सप्लोर करते हैं जो चीज़ें हमें ज़रूरत होती है, जो अपने रिसर्च में एप्लीकेशन करते हैं, जो इम्पॉर्टेंट है. We keep on learning, we keep on doing. Now let us go. There is a main tool, that is spatial analysis tool. Click on this, and then we go for interpolation, right? Then there is an option IDW. inverse distance weighted. The value may change. How the value change? If I'm here, you are somewhere here, there's a 0.10, here's 0.2, 20. So if I'm going to, it will increase. And if I go beyond this point, somewhere beyond, suppose there is a polluting unit, chimney, it is emitting, some pollutants. So if you go away from the source, the value will decrease. And if you come close, the value will increase. Very simple. So in what fashion it will increase or decrease? So inversely proportional to distance. Inverse distance, and that too weighted. Unless you do not assign weight. So this all technical issues is nothing to do with you. Just you need to know something, few fundamental issues. बाकी चीजें करके already रखा हुआ है. Nothing to worry about it, right? So I use this IDW. The moment you get the hammer, इस पर double click करो, right? Choose the input feature. Input feature is joint export map. ये हमारा है. I go and select this, right? अब ये डिस्प्ले में है तो वहां दिख रहा है. अगर डिस्प्ले में नहीं होता तो हम ब्राउज करके ले आते हैं जहां भी हमने सेव कर रखा है. वेरी सिंपल. देन Z वैल्यू, विच वैल्यू यू वांट टू इंटरपोलेट. So I do not want to interpolate latitude, longitude. What I want to interpolate? This one indices. Temperature, minimum, mean. Right? Minimum का भी mean है ये. I select this. Right? And then where it will go? Output raster there. You have to be very sure कि where it is going. Otherwise वो default format में चला जाता है, फिर हम ढूंढते रह जाते हैं. कई बार गलती हो जाती है. I click here and then I go to my drive जहाँ हम काम कर रहे हैं. This is ज्ञान कोर्स exercise 1, right? And I give here, what is this value? This value is ये है हमारा, क्या लिया था हमने, हैं? TNM and dot TIFF, TIF. Do not forget to give the extension. So what I've done nothing. Go to special NS interpolation IDW. Click on that. Give the input feature. Either it is displayed or kept somewhere else in a folder. And then यहाँ पे दिया हुआ है TNM. और यहाँ पे हमने क्या दिया? You select the parameter one by one, all the 6 or 16, 18, whatever. And then you give the output and say save. Right? Then you go and change here this output cell size. As I mentioned there, 30 meter. I put here 30. Right? क्या हुआ? 30. Sorry. 30 meter. Right? And then go to environment. Why environment? Because I want to interpolate the values within this. I do not want anything beyond that. No? So for that we go to environment and go to processing extent. There is a option processing extent. Click on this, right? And then extent, you defined extent. Extent हमारा क्या है? Basin polygon. Yes, basin polygon, and that has to be displayed. ये folder में अंदर होगा तो नहीं होगा. That has to be careful. Basin कहाँ गया? Last one, okay. Right? And then go down. 2 more issues you need to do. Raster analysis. Because that has to be converted into raster format, raster data. Click on raster analysis and then cell size. Here also you need to define the cell size. What is that cell size? 30 meter. Click here. As specified below. Select as specified below. Okay? And then it is by default 1. Put it 30. Okay? Then go down and then mask. Then go to mask. Mask as a basin point. It has to mask. It has to take it from that extent. Take the basin polygon. यहाँ तक ठीक है. ये 3-4 चीजें यहाँ आपको चेंज करना. मैं नोट कर लीजिए. यही चीज जो नोट कर रहे हैं, the same thing you have to put it in the lab. Then the last step is parallel processing. Go to parallel processing or make this parallel processing as type 0. यहाँ पे कुछ नहीं, 0 कर दिए. Processing become faster, isn't it? And then after doing this is the end, and then say okay. Right? Yes. Sorry? 30. 30 is the cell size. 30 meter by 30 meter. 30 is cell size. Then say okay. Right? तो वहां पे जो हमने चेंज किया, वहां के लिए वो लिया इनपुट सारा ओके, एंड देन you have to do okay here also. Say okay. It's running the model here. You see down, IDW. What has happened? Huh? हाँ, error आया ना? What is wrong? Just a moment. I'll do it again. Just see. We have taken this, then we have taken TMX, and then we रुको एक मिनट, रुको just a minute, let me put it. रिपोजिटरी क्या?
सर हम यहाँ पे अगर करेंगे ना आउटपुट अब आ जाएगा सही.
रुको तीसरी में क्या? वेट
सर ये रिपोजिटरी आइडेंटिफाई नहीं कर रहा है.
रुको एक मिनट. तो इसीलिए मैं कह रहा था ना कि उस मेन फोल्डर में डालना चाहिए. दैट इज द प्रॉब्लम यू मेड. इसमें नहीं डालना था. वेट, TMX ना, TNM यही था ना? नहीं यही है ना फाइल? नहीं, वेट, ठीक है ना? ठीक है ना, बोलो. ठीक है ना? TNM
सर ये पॉइंट आ रहा है ना, इसका मतलब ये आइडेंटिफाई नहीं कर पा रहा है.
तो नहीं कर पा रहे, इसीलिए मैं कह रहा था बाहर डाल दो.
जी सर डाल दीजिए बाहर.
हाँ बस,
ई ड्राइव में कहीं पे डाल दीजिए.
ड्राइव में डाल दो. तो नहीं है ना? They put it on desktop, they put it on pen drive, so that is the problem. And you have made the same problem in the lab. Desktop, never put on desktop. Should not put in this flash drive. It has to be in the main drive. And बाहर बहुत अंदर जाने पे फिर वो issue होते हैं, folder and subfolder. Then we have to define the cell size 30 meter. Rest of the thing will be same. I'll go to environment. We go to processing extent. We go to the polygon basin, right? And then we go to raster analysis. We go for same as specified below, 30 meter, and then mask as a basin. Then we go to parallel processing. We put it 0. Say okay, and then okay. It should come. It takes a lot of time because big data, it has to interpolate, triangulate. I'm sure it should not give any error. Many times you get error when you do any mistake, or there is some system error or the software error or virus. Now let us see. Can you see this one? Earlier we were having the value of only this point. Now we have the value of any place. This has made the categories. You know? This has made the different zone. You can classify these into 3 zone, 5 zone, 7 zone, 9 zone, depending upon the nature of data and how accurate you want. Right? So this is simple interpolation. And after that, this is half done. इसके आगे फिर चलते हैं. And we do this fuzzy membership. First we do interpolation for all the layers, one by one. No? And then we go for fuzzy membership for all the layers. Then we go for running the vulnerability models. Right? So quickly I'll do it. If you want to have this as a separate layer, you can make it layout straight away. You know? Or you want to have in continuation, or it is not like that कि इसमें same value होगी, but the rainfall will be varying. Even temperature must be varying continuously. But this is one step. So let us do it quickly one by one. Shall I do it? And just you see. मैं माइक रख देता हूँ. अब जरूरत नहीं माइक है. The problem which will come, that will come for the folder only. Put it somewhere else. That is a mistake you did. It will be good for you. You will get the repetition also, so that you. Sorry. We go to IDW, right? We give the input layer, same. Only thing what you have to choose is the parameter. We go to XM, the second, right? We go here and we give the, I'll put it here. What is that? TXM. TXM dot TIFF, right? Say save. Then cell size 30. Then we go to environment, go to processing extent, basin polygon, na? Same as basin polygon. Then we go to raster analysis, then say same as specified below. There is reflection also. इधर से भी reflection है, इधर से भी आ रहा है. So that is a problem. 30 meter. Oh, parallel processing, put it 0. Huh? Oh, sorry. ये जल्दीबाजी में कई बार हो जाता है. Processing extent same as basin layer. Raster analysis. Specified both 30 meter, fine. This will be fine. Mask, we missed it. Thank you for reminding. Right, then parallel processing. Is this fine? Let us see what comes. So your system is slow. Has huge data. क्या? Oh, just wait. It will do whatever. इधर इतना टाइम क्यों लग रहा है क्रिएटिंग में? हाँ, but this is good for the linear feature. नहीं होगा, कैंसिल नहीं होगा, चलो कैंसिल नहीं होगा बच्चे. So let me do it again. Go to processing extent. ठीक है ना? $30, then mask, right? Then we go for parallel processing, 0. Say okay and okay. It should come now.
We have saved it.
So it works. I made a small mistake, because of that it was a problem. So what you have, this is uh, temperature minimum and one is maximum. So if you uncheck this one, this is here, and if I click here and you uncheck this one, you will see the second layer. And the shortcut is another shortcut, good one, is that go to processing, geoprocessing. You do it just for one layer and go to geo. Instead of going that mask and all, somewhere you made a mistake, you miss it. Human error, हम जल्दीबाजी में रहते हैं, जो मैंने किया है गलती से वो गलत हो गया. So it is good, you do it one layer, जो अभी step बताया मैंने, then you go to geoprocessing and then go here, geoprocessing option, sorry, result, sorry, कहाँ गया, results, right? रिजल्ट में जाइए एंड दिस इज ITW, ये हमारा, ठीक है ना, आइदर दिस और उसके नीचे वाला, दिस इज फाइल ना हमारा, नहीं ऊपर वाला, दिस वन ना. यू क्लिक ऑन दिस एंड देन यू डू नॉट नीड टू डू ऑल, यहाँ पे ऑलरेडी बाय डिफॉल्ट आ जाएगा. ओनली थिंग व्हाट यू हैव टू चेंज इज हियर द थर्ड लेयर, दिस वन, द रेनफॉल एंड सेल साइज. यहाँ कुछ नहीं करना है आपको, एवरीथिंग विल बी देयर. And then output only you need to change. I was going on that. You change the output. What is this layer? TN90P. TN90P. Right? Oh, sorry. कोई बात नहीं, यहाँ कर देते हैं, एक ही बात है. Dot tif. We can do it here. ठीक है ना? ठीक है? यही मैं कह रहा हूँ, शैतान कहता है जल्दी करो, गलत करो. Rest you do not do, you don't have to do anything. Say okay. So इसमें बहुत टाइम बचेगा. So if you do say 20 layer, 30 layer, तो उसमें अच्छा खासा time you can save. But first time you have to do it that way. Right? I hope it should work.
सर
Results, right? And then go to this layer and only you change the two things. One is input and output. So input is R20 rainfall and then give the output. यहाँ पे आप R20 कर दो, R20 and by dot tif भी है, right? Nothing else. Am I right? say okay. Right, it works. Then go to geoprocessing, results, double click on this, and then you take the input, the second last one, CDDD, and change here. CDD, right? Consecutive dry days, nothing else. Say okay. I think it will take say 10-15 minutes more. The last layer is left. Okay, it also works well. Then the last one, results. Double click on this and give the input, consecutive wet days, and then see file CWD, right? Okay, so we have all the 6 layer interpolated. 1, 2, 3, 4, 5 and 6, right? इसका नाम गलत आ गया IDW, but this is not IDW, right? I made a mistake in typing. Now what you need to go, and that is the beauty of GIS in a sense that if I give you all the 6 layers separately in the print form or digital form, and if I ask you a location, okay, where this condition meets, I don't know, the XYZ condition, you cannot tell. So the moment you overlay, so manually if you overlay, then even then you cannot get anything. So when we do a special overlay analysis in GIS software, that will give you which one is having this particular characteristics, which say this parameter this much, this parameter this much, something like that. So for that, what we do is last option, second last option, in fact, we go to overlay, right? And we go fuzzy membership, because we want to convert these values. See, the values what you see on the left side. Here you see my cursor, 10 point something something, this is 30 something something, this is 23 something. So we go and we create fuzzy membership so that it can be on a uniform scale from 0 to 1, right? The same issue, I'll go input raster layer, CWD, and I change the folder here. And it is always good, I advise that you see what is the parameter CWD and then FM, fuzzy member, so that you remember. Otherwise आप भूलते रहोगे, हमें भी नहीं मिलता था, बड़ा मुश्किल होता था फिर, FM and dot TIFF, right? Dot TIFF and say save, right? And then this is a very important issue. There are different option: large, near, small, large, and linear. So you need to select one out of these two. How? Logically. No? Suppose this is, what is that? This is consecutive wet days. So you need to understand logically कि wet days plays a positive role or negative role. If it plays a negative role, so what I need to give? Which one I need to select? So wet days is a vulnerability. That means if you have a more rainfall, it is a basin, it is a hilly area, what will happen? Vulnerability will be more. Right? So what I need to choose is large. Isn't it? Huh? So I choose a large. Right? यहाँ पे हम जाएंगे, choose the membership type large. Right? And I say okay. Right? The same way we need to see कि किसको हमें large देना है, किसको medium देना है, किसको small देना है. And that varies depending upon the indices that you have selected. आ गया नहीं? It comes. आया नहीं है? अब आ गया. See this one. See the beauty of GIS. आप देख रहे हैं? Right? अभी था that was in bracketed. Okay, this to this much, this to this much. Now, if I put my cursor यहाँ पे, तो एक value दिखाएगा. Pixel value 0.33. If I click here, it will give the pixel value. Otherwise, when I go and see this one, इस पे हम जाएंगे, तो यहाँ पे जब जाएंगे तो ये range दिखा रहा है. तो when you go for the range, that is not very close to reality, but it is quite close. So same way, what I need to do is, I need to go for all the layers. We need to convert this IDW integrated map into fuzzy membership. So हम shortcut जाएं. Result जो मैंने पहले किया था क्यों? Then what I do is, कहाँ गया? अच्छा नीचे खींच के हमने लिया है. Right, this one. डबल क्लिक किया, हम यहाँ पे लेंगे second one, CDD, and then input हो गया, and then यहाँ पे हम change करेंगे CDD, right? Dot tif है already. Dot के पास है? Oh sorry, FM हाँ. नाम yes FM, very true. ठीक है ना? अब ये consecutive dry days, ये भी availability है. The hot days, you know, so it will be also large. Large is already here. I apply it. Let us see. Yes, it comes, right? अब इन दोनों को देखो, आप इसको चेक करो तो नीचे कुछ और है, देख रहे हैं? These are two different layers. Now quickly I do it to save time. Double click. I select the third one, rainfall, R20, R20 FM, right? Fuzzy membership. अब ये है हमारा rainfall. ये क्या था? Rainfall more than 20 mm. Rainfall more than 20 mm. The more the rainfall, more will be the vulnerable, right? So I again take the large and say okay. ये बैटरी इज ड्रेनिंग आउट, पुट इट, अभी बंद हो जाएगा. अडॉप्टर लगाओ. 3 is done. Then the fourth one. I chose TNM, TN90, TN90, right? FM. और ये क्या है हमारा? टेम्परेचर, number of hot days. More the hot days, more will be the vulnerability. So it will again a large. What happened? Yes. 4 layers. Good. It also works. The last two, I chose the second last one. ये क्या था? IDW. इसका नाम गलत हो गया. TXM. TXM. Right? I'm sorry. No. I made a mistake. I go here. Input. TXM. TXM. Mean maximum. TXM. Temperature maximum mean. Right? Now, maximum temperature again is a plays an important role, major role. So it will again large and say, okay, right? 5 layers we have made it. Good. The last one. TNM. Temperature mean maximum. TNM. Right? TNM and then minimum. This is minimum. So this will not play major role. So it will play minor role. So it will be small. Right? ठीक है भाई? I say okay. Okay, we have done all 5 layers. We have made, and you see here, for all the layers, you will have a value ranging from 0 to 1. Not below 0, not more than 1. Now see here, the value what you have, 0.7 is showing the lighter. The value 0.9, highest value shows a lighter. So you can invert it. You can change it. Or you can leave it as it is. It's up to you to read. Let me do one for just for one. Let me do it for this one. I go here, go to properties, but no, the top one is displayed. I'll go for the top one. High is lighter. Right click on this layer, go to properties just to display. Value will not change, nothing will change. I go and say invert. Check this one, invert. So lighter is high here. If I convert in check invert and apply, okay. So what is here? System is very slow, but this is I7. Imagine I7 की ये हाल है, because he has big data. बहुत data इनके पास. छोड़ दें क्या इसको? Normally what you have to do is say this one. अब देखो high पे dark हो गया. So that gives a better impression to me. कि if we have a darker, तो वो एक थोड़ा डरावना पिक्चर दिखाता है. लाइटर को कम वैल्यू रखो, इट्स बेटर. कैटेगोरिकली आल्सो फील दैट, तो ये लाइटर. नाउ एंड द लास्ट स्टेप कि बाय यूजिंग ऑल दीस 6 लेयर यू हैव टू अगेन मॉडल इट कि which area will be more vulnerable, and for that you have to do one step only. Again here, go to overlay where spatial analysis. I'll go and show it again. यहाँ पे हम जाते हैं, दोबारा दिखा देते हैं आपको. This is the main toolbox. Go to spatial analysis and then go to overlay. click on, special है से click on overlay and then you go fuzzy overlay. The title what I showed you, the fuzzy analytical hierarchical process, fuzzy overlay. Click on this, right? यहाँ पे आप input raster layer. Now my input raster layer will be fuzzy membership layer, not the first one. So I select this one. आगे आए नीचे, just click, it will come down. Second one, this is the third one, and this is the fourth one, this is the sixth one, this is, नहीं हो गया सब? नहीं, कौन सा बचा? CWD बचा. It's all well? कौन सा गलत हो गया? हैं? It's fine. It's fine. And then you give the output. अभी कुछ दिखता है चश्मे से? एज हो गई बट अभी भी किसी के बाद. Therefore I am saying कि आप आगे आ जाओ. And then this will be the output final layer. Last I say vulnerability. Underscore underscore bias, right? Dot tiff, right? Say save. And the most important, you need to apply gamma overlay type, and then gamma operation point, it is by default, it will go and say okay. Okay. Hope it should work. कोई एरर ना दे. Yeah, we got it. अब शक्ल जो सुबह दिखाए थे उससे बदला हुआ है, मैं वही शक्ल कर दूंगा. लेट अस सी. इसको हम अनचेक करते हैं. अनचेक से भी नहीं होता आनंदिता. It's always I advise to remove the layer which you do not want. Remove it, otherwise it takes time. So let us remove it. We have done all. इसको हम सब हटा देते हैं. I do not need any layer further. Just give me a minute. I hope you must not be tired. Climate vulnerability. I go to right click, properties, and then go to symbology. यहाँ पे आपके पास n number of जो भी आपको पसंद है कलर, अपने कपड़े का कलर चॉइस करते हैं ना, सूट का, कपड़े का, जो भी पसंद है वो चूज कर लीजिए. I choose red and green. So where is red and green? This one. और ऊपर? हाँ. This one. This one? Right. Red किस साइड है आपका? हाई में. Let us say apply. Right? जो हमने दिखाया था, बल्कि ग्रीन है. हमने सुबह जो किया था वो that was something different. वो था, क्या था? रेड एंड नहीं, ब्लू नहीं था. This one. This one. Yes. Revert. Invert. Invert it. Yes. This is 90% done. अभी 10% बचा है पॉपुलेशन ओवरले, है ना? तो if you can bear me with say 5 minutes more, will it be fine? फिर हम चलेंगे डिपार्टमेंट, पहले चाय पिएंगे, फिर उसके बाद कुछ करेंगे. राइट तो 5 मिनट में बस लेट मी शो यू जो करते हैं बच्चे उनको तो पता होगा बट मेनी ऑफ यू मस्ट नॉट बी नोइंग सो लेट मी हाँ है हाँ। नहीं वहीं चलेंगे ना क्यों वो क्या पहुंच गया वहाँ बोलो वहाँ पहुंचे हम वहीं पहुंचे बोलो 5 मिनट पहुंच जाए हम बस यहाँ से चल पड़ेंगे 5 मिनट में राइट सो what we have now there is another layer we have created for this course and that is the uh, basin polygon sub basin bias right this is sub basin इसको हम चेक कल हटा देते हैं आई मेक इट hollow so you can see कि कौन सा बेसिन में क्या पोजीशन है राइट सो व्हाट आई डू इज इफ आई गो इन सब डिस्ट्रिक्ट एंड सी द एट्रीब्यूट यहाँ पे हमारे पास पॉपुलेशन डेटा है where the population data so this has to be overlaid so that we can see कि what is state of affair what I showed you because हमें सिर्फ vulnerability नहीं देखना है कितने लोग impact हो रहे हैं and accordingly government has to one has to produce make the policy document कि कैसे उन लोगों को बचाया जाए कैसे ठीक किया जाए सो व्हाट वी नीड टू डू इज इसके ऊपर हम क्या करते हैं एक लाइन का ऑपरेशन है वी गो टू दिस वन जो हमारा जो बेसिन बाउंड्री है इस बेसिन का हमारे पास नो दिस वो है सब बेसिन के वाटरशेड का इसका हमारा डेटा है कहाँ से सम एजेंसीज जो पॉपुलेशन डेटा सेंसस डेटा जो हमने दिखाया था आपको व्हाट वी डू इज इस पे हम जाएंगे एंड देन गो टू प्रॉपर्टीज राइट एंड प्रॉपर्टीज में जाके वी गो टू सिम्बोलॉजी देयर इज ऑप्शन हियर सिम्बोलॉजी नोट इट डाउन सिम्बोलॉजी में गए एंड क्वांटिटीज राइट एंड देन गो टू प्रोपोर्शनल सिंबल राइट एंड वैल्यू फील्ड से पॉपुलेशन राइट एंड पॉपुलेशन में जाने के बाद देन यहां पे क्लिक करिए एंड देन गिव द साइज थोड़ा हम साइज बड़ा कर देते हैं राइट 10 पॉइंट कर देते हैं आई पुट अ कलर डिफरेंट कलर लेट्स से ब्लू कलर राइट ठीक है एंड से ओके इसका बेसिन का कहाँ गया बेसिन का अच्छा यहाँ वेट डबल क्लिक एंड आई मेड अ मिस्टेक आई हैव टू पुट इट यहाँ पे बैकग्राउंड I need to put it hollow. This is one I showed you. Right? अब यहाँ पे हम टोटल पॉपुलेशन को दिखा रहे हैं यहाँ पे हम पॉपुलेशन डेंसिटी को दिखा सकते हैं कोई भी चीज दिखा बिल्टअप को एनीथिंग सिमिलरली यू कैन ओवरले अदर डेटा अदर फीचर विच यू वांट टू रिलेट विद द क्लाइमेट चेंज vulnerability. कितना पॉपुलेशन डिस्प्लेस हो रहा है कितने पॉपुलेशन इंपैक्ट कर रहे हैं कितने कैटल पॉपुलेशन मैनी मोर राइट आई होप यू कुड हैव लर्न समथिंग सेम थिंग यू हैव टू डू इट विल नॉट लेट यू गो बिफोर यू डू योरसेल्फ राइट सो विल गो टू डिपार्टमेंट एंड टुमारो वी हैव अ 2 session by Alex here and then after lunch we'll go straight to the department and we can sit 2 hours, 3 hours as per your wishes. If you can finish in 1 hour, you're free. But you have to do it. Lab is open till 6:30, 7, 8:30, 9:30, doesn't matter. That is in our control. So I hope you should have learned something and you will be able to do it on your own. If you note it down, the steps. Yes, any problem, any issue, please let me know. Yes. बताइए आप इसमें बोलिए हम भी नहीं सुन पा Speak in the mic. Now is come on. Huh? We do it now. See, it's 4:15. We'll take 5 minutes to reach. Department is very close by, and then we have a tea, 10-15 minutes, and we'll sit and have. I hope you are not tired. Okay, then thank you so much. So this is not the closing of the day. This is the closing of this session demonstration, and then we'll do the lab. In the lab, it will be again recorded. You know. Okay, thank you.